So again, today we're going to continue with composition of functions. But we are specifically talking about inverse functions today. We're going to take a look at those. So we'll do a little more practice with just composition of functions, and then we'll start focusing on the composition of inverse functions too. Okay, so first example, it says consider the function f of x equals x plus 8 and g of x equals square root of x. And the first thing I ask you to do is go ahead and find g of 4. Well, that means we're just going to change our inputs. Our input used to be x, now it's going to be 4. So we're looking for the square root of 4. So g of 4 equals 2. Okay, that's just what we've been practicing, just function notation, changing the input and finding a new output. And then part B just asks, use the result from A as the input for the function f of x. It's kind of a weird way of saying, I want you to find f of g of 2. That's really what this is saying. I'm sorry, not g of 2, g of 4. All right. That's what this is saying here. So we're just going to take, sorry, was there a question? All right. So we're just going to take f of 2, basically. 2 was the output from g, so that's what we're going to be plugging into our f equation, which in this case is going to be 2 plus 8. So in this case, f of 2 equals 10, or what we started with, f of g of 4 equals 10. All right, so when we're composing these two functions, that's just a little example of what we did yesterday with the composition of functions. You take the output of one function and you use it as the input of a different function.
Mr. Street.
Yes.
Oh, tomorrow, since it's like your office hour, can I set up like a Zoom so I can get help with the homework last night? I had the notes, it still didn't make sense to me.
Yeah, of course. So tomorrow I have office hours from 10 to 11:30. So more than happy to meet with anybody that's a little confused. So yeah, just shoot me an email what time you want to meet during that window, and we'll set it up. Okay. That's how easy it is to do office hours. So you go ahead and send me that email now. Okay. All right. So what I want you guys to do, I'm going to break us into breakout groups in a minute here, and you're going to work on problems A through D, and just working on the composition of functions of these problems. Just a quick reminder, like for example A, it says fog, like that f of g. We can rewrite that as f of g of 6. Personally, I like to rewrite it like that, because then I can see, oh, I'm going to start with g of 6, find g of 6, and then I'm going to take that output and put that into f. There's just one that's really weird here, and I want to talk about that before I split us up into groups. And that's part D, because it says g of g inverse of x. Or I'm sorry, of 6. So before we can even start part D, we have to find out what g inverse is. So this is a good reminder of what we did last week. So we start with the g of x equals x over 2 plus 1. And we can rewrite that as y equals x over 2 plus 1. And what was the big thing we did for inverses? We take the x and y and we swap them. X equals y over 2 plus 1. And now we can go ahead and solve for x. So I'm going to subtract 1 from both sides. x minus 1 equals y over 2. And then I have this, since it's y divided by 2, and I'm out of space here, I'm going to multiply both sides by 2. And I'm just going to rewrite it with the y first. Doesn't really matter there, but I get y equals 2 times x minus 1. That's after I multiplied both sides by 2, right there. And I can distribute that 2. I'm going to get y equals 2x minus 2, or I can rewrite it g inverse of x equals 2x minus 2. All right, so I need to do that before I can be successful working on part D. That's really important there. So for parts A, B, C, and D, I'm going to send you into breakout groups, and I'm going to give you guys a few minutes to work on that, probably about 10 minutes to work on those 4 problems. All right, and come to a consensus with your group. If you're stuck on something, hopefully someone in your group can help explain it to you. All right. I'm going to make breakout groups of about 4 to 5 people per group. All right. So the breakout groups are created. Any questions before I send you guys off to breakout groups? All right, so go ahead and get on your breakout group. I'll give you guys about 10 minutes. They're coming back into the meeting. Are there any questions on A, B, and C? I've not done part D yet, but check your answers on A, B, and C. So part A, I had f of g of 6 equals 14. On part B, I had g of f of 6 equals 11. On part C, I had f of 6 equals 62. So double checking those 3 answers. And again, any questions, it's possible I made a mistake while I was solving these, so if you guys got them, please let me know if you have any questions. Okay. So we're sounding okay. And then how about part D? Any questions on part D here?
Yeah, could you just like explain how to do that one? Because I kind of like, I'm lost.
Sure, no problem. We're going to go over it, yes. So the first part, it makes sense that we found the inverse, right? Because we have to have the inverse equation in order to complete the composition of functions. So we're going to start with g inverse of x, or g inverse of 6, and I have the g inverse equation written down here. So we can say g inverse of 6, and we'll substitute 6 in for x. So this becomes 2 times 6 is 12, 12 minus 2 is 10, just following my order of operations. So I end up getting 10 for g inverse. Now I'm going to take the original function and I'm going to plug 10 in for that. So I'd say g of g inverse of 6. That's when we're doing the composition part. And the original function was x over 2. And I'm going to put 10 in instead of x, plus 1. And that 10, I'm just going to highlight it, is coming from right here, what we solved for g inverse. The output of the inside function becomes the input of the outside function. It's a really weird way to say it. Kind of tricky there, but that's what's going on. So then now we have 10 divided by 2, that's 5, plus 1 is 6. All right, that's the idea here. Okay, so one thing you'll notice that we're going to talk about a little bit today is, I'm going to use a red highlighter here. The input that we started with should be the same as the output we finish with. if we're doing the composing the function its inverse correctly. All right. Yesterday on worksheet 3, we did the last few problems, and we did like problem 5 and 6. We did f of g of x and g of f of x, and we got equals x. That's kind of like the hint that those are inverse functions. That's how you can tell. All right. Whoops. So we're gonna move down. All right, so now just gonna ask you to, on practice problems, find the inverse of each of the following functions. So you have problem A and problem B, find the inverse. So that's what we did last week. All right, so I want you guys to go ahead and calculate the inverse for part A and part B. Go ahead and start working on those two problems. Let me know if you have any questions. We already did one inverse together on part D of the previous set. But if you need help recalling how to find the inverse, please let me know. Okay, do we need another minute, or are we doing okay? I think we're doing okay. All right, so let's take a look at the first one here. The first problem, I switched the x and y, so I got x equals 5y plus 10. Now I need to go ahead and solve for x. So I'm going to subtract 10 from both, or solve for y. I'm going to get y by itself. So I'm going to subtract 10 from both sides. X minus 10 equals 5y. Then I'm going to divide both sides by 5, and I get x minus 10 over 5 equals y. And then the last step, I want to rewrite that as f inverse of x, because we started in function notation with f of x over here. So I want to end with an f inverse of x. That's how I know to switch it back from a y. All right. And x minus 10 over 5 is not the most simplified this equation could be. Technically, it's best if I rewrite this as two separate fractions. So like 1/5 times x, or x over 5 minus 10 over 5. And there's another reason I want to do that as well. And hopefully after we write it like that, 1/5 x, 10 minus 5 equals 2. After we write it like that, we should notice something about this f inverse function. And you notice why it's important that I rewrote it like that? What's it kind of look like now, this f inverse of x? What's it remind you of? Yeah. It should match g of x, okay, and that was on purpose. Now, if we start the other problem, g of x, I think this one's a little easier to find the inverse of. We rewrite this as, let's see, switch the x and y. I'm going to use the red again to do that. X equals 1/5 y minus 2. And then I just go ahead and solve for y. Add 2 to both sides. Multiply both sides by 5. So I get 5 times x plus 2 equals y. And basically, just like how we undid the x minus 10 over 5, it's like the same thing here. You have the 5 being multiplied to both numbers in one quantity. We wanted to use the distributive property to get rid of those parentheses. So we get 5x plus 10 equals y. Or we can write this as g inverse of x equals 5x plus 10. Sorry, I kind of got tight there on the side of the screen. But that's the idea for these problems here. But what we notice is, yeah, we had f inverse of x, turns out, happen to be equal to g of x. That was the big takeaway here. Something else we noticed was that g inverse of x happens to be equal to f of x. All right, so we just proved that f of x and g of x are inverses. That's what we just did. I'm kind of out of room here, but we can say that f of x and g of x, I'm just going to write it at the top here, are inverses. That is one way to prove that two functions are inverses of each other. Okay? And that's kind of like, we could call that the swap method, right? Where we've swapped the variables and we solved for the inverse, and then we did it with the other one. On your assignment 3 that's due today, you guys had a problem like that where we dealt with degrees Fahrenheit and degrees Celsius. That was one of your homework problems, was prove those two equations are inverses of each other. All right. There's another way to prove two things are inverses of each other, and that's kind of what we're going to talk about down here. It's what happens if we compose two inverse functions. So now that we know these are inverse functions, what happens if we find f of g of x? So we're going to take our g function and make it the input of f. So f of g of x equals, the f function was 5 times, and now the input function, 1/5 x minus 2, and then plus 10. So I'll highlight the g of x real quick. So there's our g of x, and that's where this x became the 1/5 x minus 2. Okay. And if we compose these two functions, I can distribute the 5 here. And I'm going to get 5 times 1/5. What's 5 times 1/5? Or
1.
Yeah, it's just 1. Anything times its reciprocal, because the reciprocal 5 is 1/5, is just going to be 1. And then 5 times -2 is -10. And then we can't forget about that plus 10 that was added on the other side. Whoops. So we end up with x minus 10 plus 10, or f of g of x equals x. Okay. And then part B, we're going to do g of f of x instead. So we're going to say, hey, that's weird. On part A, we ended up with f of g of x equals x. On part B, we're going to do the opposite, g of f of x. And I'm just going to highlight this one real quick. F of x, whoops. F of x right there. And this time when we plug in, we're going to use the f function as the input into the g function. So 1/5 times 5x plus 10 minus 2. And this time I'm distributing a 1/5. So I get 1/5 times 5. That's 1x. 1/5 times 10 is 2. Oh, and I just do want to highlight this in green just to show you this is where the input came from. All right, but I got x plus 2 minus 2. And that gives me a final result, g of f of x equals x. All right. So that's how we can prove, using like the composition of functions method, we can prove two things are inverses as well. And that's just whenever you get two composed functions equaling x. All All right, then you're going to end up with a what's the word? You're going to end up with a inverses, f of g of x. That's how you prove their inverses, just like that. All right. So specifically, we're looking for f of g of x to equal x. Two different methods from the top and the bottom for finding or proving the two functions are inverses of each other. Any questions about this so far? No? Okay, good. It's just a little review practice. So this last part, I'm just gonna ask you guys, to go ahead and complete this table here. So I give you this equation, f of x equals x minus 4 quantity squared. And what I want you guys to do is go ahead and fill out the table. So you got to plug in values for x. So like f of 2. So 2 minus 4 is negative 2. Negative 2 squared is 4. That's how we'd find like the first value. I want you guys to take a couple minutes and fill out the table, find the inverse, and then graph the function and its inverse on the right-hand side. And then we're going to identify domain and range. This is kind of what we did last week on Thursday and Friday. And then we also need to write the equation of the inverse down in the bottom right-hand box. So a little review practice for us. Go ahead and take a couple minutes to work on that. If you're stuck on something, or if you don't remember how to do this stuff, let me know. I mean, it's been a few days. We had a weekend in there. Okay. But this is kind of what our first assessment's going to look like, is we're going to have problems like this on it. So you got to be able to break these types of things down. Finding inverses, identifying domain and range, and graphing. Let's go ahead and talk about this problem. So I filled out the table. Again, you just take the inputs, f of 2, f of 3, f of 4, f of 5, f of 6, you plug them in, and that's going to get you the values, the 4, 1, 0, 1, 4. And then to get your inverse, you just have to switch the table. So the outputs of the original become the inputs of the inverse, and the inputs of the original become the outputs of the inverse. And then we can sketch our graph. If you don't have colors, you got to make sure to label them. So you can label your f of x, you can label your f inverse of x. Just that way you can tell which one's which. Really important to label everything. For domain and range, I gave you a little bit of a hint here. I wrote down the word quadratic for f of x, because the domain of any quadratic function is always going to be all real numbers. It's negative infinity to positive infinity, any quadratic. All right, any x value should work for a quadratic function. Okay, and then we just have to identify the range of that function. And what happens, because we're squaring numbers, we can only end up with like positive results. So that's what we're seeing here on this graph, is we see it looks like the y values get down to 0 and then go up to infinity. So the range is going to include the number 0 because it's included right there at 4, 0. And then it's going to go all the way to positive infinity. And when we get to an inverse function, we just switch the domain and range. So as long as we can identify the domain and range of the original function, we should be able to identify the domain and range of the inverse function. And then the last part, the equation, I went ahead and wrote it down as plus or minus square root of x plus 4. And just if we need to see that real quick, we would start with y equals x minus 4 squared, switch the x and y, and then you square root both sides. And as soon as you square root both sides, that's where the plus and minus comes from. If I don't have the plus and minus if I were to try and graph it in Desmos without it, you would see that it doesn't look the exact same. That's why the plus and minus is super important. And then another important thing here is when we add 4 to both sides, the 4, first of all, it doesn't have the plus or minus in front of it. And second of all, it's not in the radical. So we can write it 2 different ways. You can write the 4 in front of the radical, like this down here, or you can write it like I did and clearly show that the 4 is not in the radical. So I wrote plus or minus square root of x, and you can see that there's that part right there. And then the 4 is clearly not attached to that radical, plus 4. All right, so 2 different ways to write the exact same equation. Either one of them is correct, okay? But that covers everything from there. All right, any questions on today's lesson? Okay, so tomorrow we're going to be covering our first discussion topic of the year. It'll be a graded discussion, and I'm not sure what the topic's going to be, but I think it's going to have to do something with proving 2 things are inverses, maybe with 2 different methods, one being a composition of functions, one being just traditionally solving the swap method. So that'd be my guess on what the discussion topic's going to be tomorrow, but I'm not really sure. What do you guys think? Question?
Do you still have advisory tomorrow?
I do have advisory tomorrow. So advisory is going to be 8:30 to 9:15. And remember, tomorrow is not we don't have a formal meeting time for class, but we'll just have the lesson posted on Canvas. It'll be posted by 8 a.m. And you guys just do it whenever you want tomorrow, okay? So you just complete the discussion topic and you turn it in, okay? And it'll just be like an assignment that we turn in, okay? It'll have an assignment turn-in time and things like that. That's what tomorrow is going to be. And it's probably something that'll take you about a half an hour, I'd say, at the most. If you know what you're doing, it should take less than that. But that's the idea for tomorrow. Again, I'm guessing that it's probably going to be on either proving inverses by swapping and solving, or proving inverses by composition of functions, probably something like that.